just a general method. I can fit that. Just 4 operations, etc. But we basically divide the distance. So we have a step counter. We'll set it to 0. We will add the distance divided by our greater step, and that is integer division. We won't have a decimal or anything. So if you have a distance of say 61 and you divide it by 10, you get 6 for
there's gonna be one
for 6 steps.
I'm trying to write that up as you're doing it.
And I don't know. I'm not going to write all of it exactly.
That's fine.
But the next step would be you check to see if your remaining distance is equal to your smallest step, in which case you add 1. Because we know that we only need 1 more step. But if the remaining distance is greater than that, or smaller than that, if it's not equal to the smallest one, then you just add 2.
So remain is your distance minus step.
Oh. I should
What you talking about?
I should add another condition. If distance
then you can't do the
mod your greater step is not equal to 0, because then we don't need to add any steps because it multiplies.
So that and remain, or is
no,
it
it's
two
just
separate things?
separate checks.
Okay.
So the first thing you do is you add the step, your distance divided by your greater of the 2. Then you check to see if your distance mod greater is equal to 0. If it's not, then you move on. Otherwise, you just print steps. If your remaining distance is equal to your smaller length, you only need to add 1. But if your remaining distance is too small for that step, you're going to need 2. And if that remaining distance is too big for your smallest, but too small for your biggest, you still need 2. So you have 3 cases where you don't add any extra steps, you add 1 extra step, or you add 2 extra steps.
So if E mod greater is not equal to 0, you said you do what? What step?
You would just print it.
Okay.
Because you don't need to add it.
So
You don't even need that. You could just say continue and then just put a print step at the bottom.
the thing is, this is reading for like each query though.
Oh no!
Oh, you're saying this.
Yeah.
Well, I mean, you wouldn't even need that whole thing then.
No, you need that because you need to check to see if your distance divides in even. If your greater step, like if you have a distance of 60 and your largest step is
I see what you mean.
6,
Yeah.
you don't want just a raw else there saying +2 because you're going to have more steps than you really need. And then just after all of that, you print your steps. Why do you have the for I in range though? Continue.
That's the number of queries. Remember, they give you multiple.
Right.
Yeah. So.
But yeah, that should do it. Should.
And then you get
Yeah, that's one thing is you should make sure that yeah, if it's integer division, Python's automatically gonna round it down
Yeah.
because we're not using fractions on this. So.
It's only doing that case though. It's only running on the first one, I think. You're doing it for Q times.
That might be it. Yeah, it's probably continue is my bad habit of mine.
I think.
0, 2. Okay, so wait, let's look at the last one. 3, 4, 11 we've got here. What would it do? We divide it out so it would be 2, which it would have. The distance remaining is 3, so scroll back up.
Yep.
D minus step. That doesn't make any sense because that would
Well,
come out to.
Who's your remaining then?
Is there an operation in Python where when you divide you get the remainder?
Yeah.
Because that's what you need.
It's is it Gmod? Oh yeah, if you but you only want the remainder?
Yeah, that's all.
Yeah,
you need.
yeah, you just do mod then.
Yeah, that should do it.
So dmod step.
Yes, your greater step. Dmod your greater one.
If that's equal to small.
Yeah, that's what you want.
Okay.
Zero, two, two. Okay, let me see. 4. Because
I get what you're thinking on that though. It's like if the distance you have left is like a multiple of smaller.
If the mod is equal to 0.
Ah, this one.
That's
Yeah.
that's the catch for this second.
Okay. Not.
Hey, look, it passed the sample case.
So we basically move
Fail.
Epic fail.
Oh, it failed one. Failed a bunch of them.
Get what you're thinking. There's probably just some type of input where it wouldn't work. I don't know.
Maybe. I suppose if it's, I suppose this only works if it's an integer step, but it should just.
I think it is. I don't know.
Is the distance an integer though? Yeah. This was the solution I came up with, but I didn't actually test it, so I wouldn't know. For
Well, that's a general thing.
certain. Yeah.
Yeah. So if that one works. Yeah, that one actually does work.
We
Wow.
were working on new problems today.
Oh yeah. Well, I mean, we don't have to do both of those, but I actually am a little prepared today. You know.
That's it. Yeah.
One of them I have I already like wrote the solution to them both earlier. One of them it's great. It's like generators to the rescue. Like I looked into the discussion and people were talking about what does a DP stand for? Like have you ever heard like DP being commonly used? DP. Yeah. I don't know what they mean. Oh, wow. Wow. Okay. People kept talking about that for them. And stuff, and I was like, these aren't that complicated for anything, you know, fancy. Like, these are pretty easy, actually. They're simple. That guy from the discussion on this problem, though, was like just laughing at us. Yeah. It's not that hard, guys. Yeah.
So in the triangle phase.
Y'all can keep working on that one if you want. I've got
This is bugging us.
I've got a couple new problems here too, though. So one of these is super easy. Well, they're both really easy, actually. For some reason, they're rated medium. This one is basically Fibonacci, but not your typical Fibonacci. Pretty much what it is they define Fibonacci sequence as what you see up there. T, it's like instead of normally you have T I plus 2 equals.
We got it.
You submitted it and it worked?
Yes.
You thought we were moving on.
Oh, no. Alright. You wanna put yours up here? Or do you just wanna like go through the algorithm you did?
Well, we did, for sure. Alright. Crap, pull up.
As he gets up here, his laptop dies.
No.
No, I'm just kidding. It's not like it's going on the leaderboards, guys.
Alright,
Contest is
so here's how it works. We get all the numbers, right? First we gotta check D. Just see if it's 0, and then we can return 0. And that's one case that we look at.
one out of many.
One out of, I think, 3, or I don't know. Then we have to get the maximum and minimum numbers. So we just get the max of A and B, we get the min of A and B. What else do we do? There's this interesting thing where, like, just without even looking for like how many steps there are, stuff, we can just check and see if our maximum number is greater than half of the distance that we have to follow. And if that's true, then we can just say it's 2 steps, because we can do a triangle thing, and that works. Then, after that, there's basically no other like special case, really. So now we have to actually do divisions and stuff. So we get like an initial number of steps, and that's just the integer division of, wait, no, yeah. The distance we have to go divided by the maximum number of steps that we can go, or x positions. And we also grab our current x position by multiplying steps by what's it, MA? Oh no. Yeah. That. So we get our x position after all that. And now we can do, like, there's either, like, from this point we're either on the spot we're on, so we can say, oh, just print out steps, or there's like a little bit of distance left. So basically we can figure out from there, do we need some sort of triangle at this point? So figure that out. We just basically check if we need to use the minimum distance. Like if that minimal distance is what it is, I don't know. So trying to figure out how to explain this. If we're only that minimal distance away from the end, then we can just add 1 and be done with it. Although in this other case I'm about to show you, we can also add 1, so I could probably take away an if statement. But the thing he found out is that, like, so say we had to like move 12 spaces, we have like 5 and then some random number, -1, don't worry about it, as our moving spaces. We can move 5, we can move 5, and then we'd have like 2 spaces left to go. He found out
That's
is
where your
that,
code was running into the issue. It would add 2 to the end,
yes.
but it only needs that 1.
So instead of just doing the triangle method here and adding 2 steps, you could do a triangle method here, and it'll only be 2 minus 1 steps, or 1 step plus however many steps this is. So basically say, if I need a triangle at this point, you just add 1. And that's the algorithm. Very poorly explained.
Easy peasy. Well, I get it, but
Cool.
after
And the
it doesn't
entire-
even have my old submissions anymore. Where okay.
Okay.
Oh well, but yeah.
After like 2 weeks.
So if you want to send me that code or do like a request or something to GitHub, I can put it on there.
I'll add it. I'm gonna have to delete a bunch of stuff because there's like a bunch of things on here that
Yeah.
I don't need.
Oh, that's the wrong one. Anyway, so this problem is like they give you a different equation for Fibonacci, where regular Fibonacci is ti plus 2, so it's like the second one after whichever one you're on is equal to the 2 before that, plus the 1 directly before that. So instead they've got it defined as t, the one like 2 before it plus the 1 directly before it squared. So it's, if you know how to write Fibonacci, it's really not that hard at all. So in Python you can do it with a fancy generator, like so you just write it as a normal function. However, the thing is, with this problem, they give you the 2 numbers that they want you to start with. So that's what the first 2 numbers are. They give you T1 and T2 and then n. So they're asking for the nth Fibonacci number starting with these 2 as your initial ones. So it's like, just instead of starting with 0 and 1 like the most updated version of Fibonacci does, you would start with whatever they give you. So you can take 2 things there, and with a generator, yield is like your thing that it'll give you every time that you call next on it. Then you can do see, it was T1 plus T2 squared is how they defined it. So that's your generator. Or actually, you need an infinite loop. That was weird. Anyway, so that's your generator, and then you can create the actual generator with this. So I'll say read in the numbers, and then all you have to do is pass them in. And then as far as getting the nth one, the way generators work in Python is you just call next and pass in the generator. So it would be next fib. So I'll just do that for for n number of times, so that we just basically throw away all of the numbers up to n. Actually, I think it's in. Yeah, you would go n minus 1 and then print out the nth one. So I think that worked. Yeah. Wow. First try? Totally didn't solve it earlier. But yes, it's like, if you know how to do regular Fibonacci, it's easy. And doing it with a generator here makes it convenient, since you don't end up wasting a lot of stack space calling like recursive calls. So it's kind of convenient. Well, with Python, it's weird how you can do this. It's like you set T1 equal to T2, but then you set T2 equal to T1 here plus that, and it uses the old value of T1. Like, it's weird how it executes it. Like, it's all in one line, but the way you would think about it is whenever it gets to this part, T1 will equal whatever T2 was, but it's not that way. So I don't know. It's very strange. It works. So yeah. So this one's even easier than the other one. Other one I've got is a recursion one, and so basically they've got a guy, Davis, who likes to walk up his staircases in steps of 1, 2, or 3 because he's cool. Yeah. Sounds like a friend of mine, I know. Anyway, and he wants to know how many different ways there are of walking up a staircase of n steps, basically. So they give you first a number that tells you how many queries or how many like different staircases there are, and then for each staircase they tell you how many steps. So I started thinking about this one at first, and like it'll kind of click if you think about it. So it's like, as far as the recursion part goes, you know, there's only going to be like 3 things he can do. Like you can, if you have a function that's like calculate for a given staircase of n steps, then there's only like 3. There's 3 like n cases, right? There's going to be like if n is equal to 1, so if the staircase is only 1 step, then obviously you'll return 1. And then there's the case if it equals 2. And keep in mind, this is the number of ways he can go up it. So in this case, he can do it 2 ways. He can either take 1 step of size 2, or he can take a size step of 1 twice. So you return 2. And then if it equals 3, then he could do 1, 1, 1. He could do 1, 2. He could do 3. And he could do 2, 1. So 4 would be what you return. And yeah. So there's this case too, which won't make sense until I get to the recursive part, but you'll see. So now those are all the terminating cases, and then for the actual recursion, all you have to do is like basically if it's like the staircase is greater than his largest step size 3, then you want to add up all the different ways for him to go up the staircase, taking like 1 step off each time, if that makes sense. Like so that would be, yeah, so it's like, yeah, I don't know, it makes sense. Like I don't know how to explain that, but it makes sense. It's like with each of his step sizes, if you take that off of it. So the reason I did this condition is, say you had a staircase of size like, actually no, I don't think you need that now that I think about it. I was thinking this might come up passing like some negative numbers in at some points, but I don't think it would. Yeah, but it would catch this if you have a size 1. 1, 2, 3, and then if you had size 4, then 3, 2, 1. So I don't think you need it. Try it. Yeah. So then we have to actually solve the problem. Oh, yeah. What am I doing? Yeah. Yeah. So then yeah. The first time I was looking at it earlier, I didn't actually read the part where they were talking about how Fibonacci was modified, so I just used a regular Fibonacci sequence. And I was like, well, this isn't hard. You just start at a different spot. But oh, okay. Yeah, so here's another interesting thing about this problem. It's going to time out on the rest of them. So the input or whatever, yeah, it's like we've got 3 recursive calls for every call of that function actually, so it gets pretty intense. If you look at the top, they give a suggestion. It's like, oh, read this to learn more about recursion and memoization, however you say it. And I know what that is, but I didn't know it by that term, so I had to look it up. And basically it's just caching. So what we can do to speed this up so we don't get these runtime the timeout errors is keep a cache of all the inputs that we've already given. So what we can do is like just make a global thing. I don't know. Just call it outputs or something. And for every basically you want to check if your input to the function, so in, if that's not in this dictionary outputs, which so you know, a dictionary in Python is just a map. So it's like you have your keys, like one in our case. So it's like we're using in as our keys. So if you pass in 1, it's going to return 1. We specified that. And 2 is going to return 2. 3 is going to return 4, and so on. So we'll keep a dictionary for all of that. It makes it really easy. And you say if in is not in the outputs, basically if it's not one of the known keys, then we'll take the actual calculation of it and store it for that key. And then afterwards, all you have to do is return the value for that. So now it's not going to actually do all this recursive calling mess every single time, only when it needs to. So hopefully should work. And you notice it runs a lot faster with all of the test cases. Yeah, it's like just flies through them. So that's why caching is nice. Although this is like, I guess you can call this caching. But
Is caching the concept?
yeah. No, it's like if you look up memoization, oh, I still don't know how you say that. Yeah, so see, I guess they use Fibonacci as an example for it. Right. It's like store it. Yeah, you use a table. So pretty easy. But I think you have to use that kind of caching stuff to actually pass this problem, I think.
So
If you're doing it recursively, at least.
basically what I'm getting is, as it goes farther on, if the sum of these 3 calculations would be the same, instead of actually going in and running all of those, if they've already been done before and put in outputs n, it just refers to that
Right.
outputs n.
Yeah.
Okay.
It's like, so it saves, you know, like really, it looks like just 3, but it really saves a bunch of recursive calls. So that's like 3, but it grows exponentially. So
It's basically just storing numbers and saying, hey, if this number is not already in here, actually find them.
so neat. Yeah, I guess so. Like, I don't know if you don't understand this though. Basically, it's like if you think of the total number of ways he can go up the staircase, you got to think of the number of ways he can go up the staircase, like starting with 1 step, or starting with 2 steps, and starting with a size 3 step. So you just add all of those together, and that's the total number thing. Like if he also liked to jump really far and take a step size of size 5, then you would have to add that one on. But you know, it's always weird to explain recursion, like the actual recursive part.
For a second, I was trying to think, what have we done in stats where we can try and figure this out? And I thought, it'd probably take a lot longer.
MATLAB. Can't wait until we talk about R in there. No, thankfully. You're not supposed to. Like, that's just something I think he's doing. Only it's in the curriculum. Anyway, that's...
Cutting a bunch of stuff out of this syllabus anyway.
Hey, it's fine with me. So yeah, but yeah. So that's all I've got tonight though. That was a pretty quick rundown, but I knew I was probably gonna cut it short tonight. Then next week, I'm gonna talk a bit about cryptography, what I know of it, and I get to refer to a book I was writing this summer to actually remember it. So, yeah, I have a chapter on cryptography, and I was like, oh, yeah, it's so basically you can write like your stuff in Markdown and store it actually on GitHub, and like this site called GitBooks uses like GitHub webhooks and stuff to work with it. However,
What is the significance of 192 bits?
huh?
It said 128, 192, and 256.
They're
Oh, and this, yeah, that's the key size for AES. It's just,
divisible by 8.
Oh, okay.
yeah. But however, I will warn you, if you want to use Gitbook and you're using the editor that comes with it, keep in mind that every time you save, it considers that it actually makes a commit, and you might end up with 91 contributions in a single day if you're like me and you hit Control S all the time. So,
Well, you really have to go and keep those.
it's like an employer is going to look at that one day and be like, wow, what did you do on June 28th? And like, hit Control S a bunch. Yeah, so, but it's pretty cool though. Like, so like you can, yeah, it's like you can store it on here, and there's that. You can download it as a PDF, ebook, and stuff like that, and then you can read it directly on their website, which is what this is doing. So it's pretty neat. I enjoy using Markdown a lot more than like Word. So, but if, like you can also just view this on GitHub though. Yeah, so it's like you just store it in a certain like the way that they want you to on Gitbook, and there you go. So cool. But that's all I've got for tonight. Yeah, and then sleep at some point.
Do you guys want to go get something?
I think I was gonna cook something.